In today's math lesson, while looking at the slope-intercept form, we are going to write an equation from a graph. Recently, in a previous lesson, we discussed the 4 different slopes of linear functions. And when you have to write an equation from a graph, it is very, very important that you look at what type of slope you are having to work with. Otherwise, building this equation will be very, very challenging. As we looked in previous lessons at the 4 different types of slopes, we told ourselves a silly story to help us process what is going on in these particular situations. We started with a man being on the left side of your line. Regardless of where your line is pointing, we always started him there on the left. And then we said, he died. He died. And he heard the voices, and he saw the light, and he followed his path up the direction of the line. And if he is pointing upward as we move to the right, a person might say that they are going up to, eventually, heaven. And heaven is considered a positive experience, that is a positive slope. But the man being on the left, I don't know what happened, I was not there. He died, followed his path, followed the light, but his path is going downward. And one might say that he is slowly going to hell. Those are flames. And hell is considered a negative experience. This is a negative slope. Now, some people believe that nothing happens when you die, or they believe in purgatory. Either way, you're just sitting, waiting, doing nothing, flat, waiting. And so that is a 0 slope. If you believe in nothing, well, that's a whole lot of 0, which is nothing. And if you believe in purgatory, then you're waiting as nothing happens, and your parents, your family is trying to pray you out. There you go. Undefined slope, we talked about in the previous lesson as being that no, Elvis Presley didn't actually die. He was abducted by aliens, and aliens, that's a spaceship, aliens are undefined. There you go. So here's the quick review on your 4 different slopes, and I hope that helps you. Example 1. As we look at this graph, we have to determine the equation of the line in slope-intercept form. Quick review. What is the slope-intercept form? Yes. Y equals mx plus b. So what does that have to do with me? Or you, as the case would be. You have to find the slope, and you have to find the y-intercept. Let's see how this goes. Truthfully, this whole lesson is going to be a big review of several lessons that we've done very recently. Let's start with B. It's a nice place to begin. So finding B, your y-intercept, is really pretty friendly and not too stressful. We say here is the y-axis, and where did my slanted line cross the y-axis? Right here. This is B. That is your y-intercept. So we can quickly just say, B is -6. M takes a little bit more work. Let's go find out what it is. First things first, is this a positive slope or a negative slope? So looking at the introduction, thinking about the silly man who died, and then followed his path as he heard the voices and saw the light, he is definitely moving upward towards heaven. This is very much a positive slope. And we learned in the previous lesson that a slope always has a rise and a run. Now, another previous lesson that we have worked on was just finding the slope. And to do that, we had to find 2 clean coordinate points. So the y-intercept is a great clean coordinate point to work with. We have options on this particular graph. This is a clean coordinate point. It's right in the corner of our axes. And we have another clean coordinate point right there. So you have multiple options as to which clean coordinate point you want to use. You don't want to use any of these as they are not right in the corner. That's really close to the corner, but not perfectly. That one's perfectly in the corner. Okay, so now we're going to build our right triangle. And I am going to use my top point and my y-intercept. You have options, but those are the two that I am going to use. Remembering that the vertical movement, this is your rise. The horizontal movement, this is your run. So our rise, as the scales for x and y are the same, our rise happens to be, count the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. And our run happens to be 2. So our rise over the run, as yes, it is a positive slope, so I don't have to worry or do anything with that, will be 14 over 2. And if you can reduce your fraction, yes, you should. 14 divided by 2 is 7. We are now ready to go ahead and write our equation. We've done all the hard work. Let's just put the numbers where they go. Y equals m, my slope, which turned out to be 7, x, and our y-intercept is -6. So you never place a plus and a minus side by side. If your y-intercept is positive, just use the plus. If your y-intercept happens to be negative, as ours is, you just write -6. And that is the equation of our line. And there you go. Example 2. After looking at this graph, we are going to determine the equation of this line in slope-intercept form. What do you have to find? Ah, yes. You have to find the slope, and you have to find the y-intercept. The y-intercept is super easy and friendly. We can go ahead and find that first. So B, your y-intercept, is a great place to begin. As the case would be here, our y-intercept, where it crosses the y-axis, is right there. That's B. It's at -4. Let's go look at M. So now that we know where to begin, let's find out how we move. First off, is this a positive slope or is this a negative slope? And if you go back to the introduction with our silly story, there's a man who starts here standing on the left, but he died and he followed his path and he saw the light, he followed the path, and this man is very quickly going down, 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 down to hell. This is a negative slope. So now that we know that this is a negative slope, we remember we have to find a rise and a run. And we do that using our 2 clean coordinate points. We found our y-intercept here at -4, and we've got a whole myriad of clean coordinate points to choose from. We could use any one of these, lots and lots to choose from. So for simplicity's sake, since our line crosses the x and the y axis nice and clean, let's use those 2 points. Here is our rise. Here is our run. Our rise is 1, 2, 3, 4 units. And since it is a negative slope, we will say -4. Our run is 1, 2, 3, 4 units. We don't place a negative again. It's done, it's over, it's accounted for, it's acknowledged. Just one negative will suffice. And then simplify and reduce, because it is possible and you should do it. -4 divided by 4 is -1. Now that we have found out what our slope is, let's go write our equation and call this a day. y equals negative 1. That is my slope. That is my m. Negative 1x, as x comes after your slope, plus b. And we stated in the previous example that if your y-intercept is a negative number, you just use the negative that's on it. You don't have a plus and a minus side by side. You just use the negative that's on it if your y-intercept is negative. Truthfully, you don't have to show the 1 in front of the x. You could just say negative x minus 4, and that would also be very correct and very acceptable. The 1 can be understood. And there you go. Example 3. After looking at this graph, we are going to write the equation of this line in slope-to-intercept form. Let's get started by finding out what we're looking for. We need to find our slope, m, and we also need to find our b, our y-intercept. Let's start with b, because it's quick and easy. We like things that are quick and easy. So b, your y-intercept, is right here. What value is that? Ah, yes, negative 2, as this is where our line crosses the y-axis. Okay, now that we have found b, we have to find out how we move. We found out where to begin. Let's go find out how we move. So, is this a positive slope or a negative slope? We put our man on the left, and then when he dies, you follow the path. He heard the voices, he saw the light, and this man is very, very quickly going down, down, down to hell. There are the flames. So this is a negative slope with our rise and our run. So we need 2 clean coordinate points. Let's see if we can find them. We have the y-intercept as one of those clean coordinate points. And then, let's see, not clean, not clean, not clean. That one's clean. We like that. Not clean, not clean, not clean. That one's clean. We like that. Or not clean, not clean. This one would work. So we have options. We have lots and lots of options. So let's use them wisely. We can choose, any 2 of them. It does not matter. I'm going to choose this one all the way up here and come down to my y-intercept, knowing this is my rise and this is my run. With my rise being 1, 2, 3, 4, 5, 6, 7, 8 units, and it is negative slope, so this is negative 8. And my run being just 2 units, and we can write these on here. Remembering that a negative only goes out in front or on top of your fraction. You do not place another one below it. And yes, we can definitely reduce 8 divided by 2. So negative 8 divided by a positive 2 is a negative 4. Now that we have our slope and our y-intercept, let's write our equation. Y equals our slope, how to move, of negative 4, then our variable x, plus b, except that our y-intercept is a negative, and we don't have a plus and a minus side by side, so we just write the minus 2 at the very end. And there you go. Example 4. After looking at this graph, we are going to determine the equation of the given line in slope-intercept form. Knowing that our slope-intercept form of the equation is y equals mx plus b, let's go find our slope and our y-intercept to help us see what we've got in our graph. Step 1, B. Where to begin? Our y-intercept. So the y-intercept, as always, is where our slanted line crosses the y-axis, which you can see very quickly is right there. Here it is, at negative 2. Let's go find m, how to move from there. So we need to know, is this a positive slope or a negative slope? And just as we have discussed previously, if you draw your little man here on the left side of your graph, and then follow the direction of his path after he hears the voices and sees the light, this particular fellow, when he died, he went down, down, down to hell. There are the flames. So this is a negative slope. As we know that the slope is always a rise and a run, we need two clean coordinate points. So our y-intercept is definitely one of those clean coordinate points. Let's go find another one. Here's one. Here's another one. And there are other options here on the other side of the y-axis, and that's just fine. We can use any two of these points. As the case would be, I am going to use these two right here. So here is my rise. There is my run. So my rise is 1, 2, 3, 4, 5, 6 units. This is a negative slope, so it is a negative 6. And my run is just 2 units. So we don't need to put a negative on the top and the bottom. Just the top or out in front will suffice. Negative 6 divided by 2 is a negative 3. That is our slope. Now that we have the slope and the y-intercept, let's write the equation of our line with y equaling m, our slope, which is negative 3, the variable x coming after the 3, and then plus b. Since our y-intercept is negative, we don't write a plus and a minus side by side. We just use the minus that we've got, which happens to be a negative 2. And there you go. On our fifth and final example, after looking at this graph, we are going to write the equation of the line in slope-intercept form. I really hope that you're feeling confident in these problems now as we look at our graphs to determine the slope and the y-intercept from a given graph so that we can then write our equation. Step 1, let's find your y-intercept. As the y-axis is here in the center vertical, and we see our line is really low on the graph, and that's just fine. This sometimes makes people a little bit nervous because the line is all the way down at the bottom, just barely intersecting the y-axis on this portion of the graph that we can see, but that's just fine. Your y-intercept is still right there. It is b, sitting at negative 100. Okay, let's go find m. So now that we know where to begin, let's go see how we move. And we know that we have to determine if this is a positive or negative slope. And we've been doing that with our silly little story about a man who died, and he heard the voices, saw the light, followed his path. And this path, while it may be taking a while, he is moving upward. He's going to get there. So this is moving upward, eventually slowly getting him to heaven. This is a positive slope. Knowing that a positive slope, I spelled that wrong, is rise over the run, let's go see what we've got, looking for two clean coordinate points. Our y-intercept is clean. We'll definitely use it. Here's a clean coordinate point. Here's another clean coordinate point. And that's all we need. We don't need lots and lots of them. We just need one, truthfully. So let's go do this. We can pick any two. Here's another clean coordinate point. Why not use one that's not on the y-intercept? Why not? Just for something different. So our rise is vertical. Our run is horizontal. And we see that our rise is all of 2 units. And we don't have to worry about a minus in this example, as our slope is positive. And our run is 1, 2, 3, 4, 5, 6 units. You definitely need to reduce this if possible, and it is possible. 2 divided by 6 is 1/3. And having a fraction for a slope is just fine. It will happen more often than not, truth be told. So, y equals m, our slope, which is 1/3, x, our variable, plus b, but our b, our y-intercept, happens to be negative, and we don't put a plus and a minus side by side, so we write minus 100, and so thus we have our final equation. And there you go.